Welcome to Stories in AI. Today we speak with Laszlo Sragner. He is a founder at Hypergolic, based out in the UK, and it's a firm focused on helping organizations scale their data science efforts through consulting, education, and implementation. Now, Laszlo has an amazing background, from hedge fund to hacking human emotion and intent at Candy Crush Saga. He started a Substack newsletter which is full of gems of information on how do you really structure and scale your data science efforts. We talked about a bunch of different things: building data-defined products, challenges in productionizing machine learning, use of Agile methodology in data science, and training data scientists a little differently. I really enjoyed the conversation, and I hope you do too. Laszlo, welcome to Stories in AI. How are you doing today?
Thank you very much. Thank you for having me.
Oh, it's great to have you here. And, you and I met not long ago, but I was such a fan of some of the writings you had at Substack about how organizations approach AI and what are the challenges in scaling it and how do you really come about it. But before all of that, right, why don't we just start off with, tell us the story on how you got to AI, what got you interested, and give us your history.
I actually got into AI in 1999. I needed to select a major for my master's studies in Hungary. And because I was stronger in math than in engineering, I went for a highly mathematical subject. And that's how I got into it. And after I studied for a PhD for 3 years, 1 year in Belgium. And when this finished, I said, whether I should go back to Hungary or maybe I get out of the program and go for the industry, and was looking for who is hiring machine learning engineers, and it was an extremely unpopular subject at the time, and I recognized that there are these companies called hedge funds in London that are doing time series analysis, and they were pretty much the only people who were hiring people who are doing machine learning. And so I came to London and worked for hedge funds in finance for 7 years, specializing in commodities and quant trading.
Yeah, no, that's awesome. So hedge funds, financial services has always been kind of a leading indicator of where market is going to go. So I'm not surprised. Now, how did that transition happen from hedge funds to Candy Crush Saga? Tell us that story.
Yeah. So this was around the Greek crisis. I think it was 2010, 11, 12. That was a very bad period for commodities, and I was looking to do something more interesting, and big data started to become bigger. And I was thinking that maybe I was always more of an engineer and on the technical side rather than the financial side. So I said this suits me, and I joined King Digital in their London studio. So and the work what you're doing in business intelligence is remarkably similar to what you do in hedge funds. There is a lot of analysis and understanding and looking into the domain, what's behind the actual numbers, and you need to create like plausible explanations of why something is true and why something is happening. And it wasn't as big of a transition as people would think, because of this insight. But it was indeed more analysis because of the size of Candy Crush and the other titles. Descriptive statistics is almost as good as modeling, and there was a lot of interesting insights there, because of the scale and the variety of people who are playing it. You are capable of driving psychological understanding of what's happening in the people's head, what they are doing. So that was a very, very intellectually challenging and interesting work, what I did there.
That's amazing. So you were basically figuring out what's causing people to stay on the platform, what is causing them to invite their friends, just getting into the human psyche through machine learning at the time and statistical analysis.
Yes, indeed.
Start with the previous question. So Laszlo, where in the world is AI today? What's happening? What's working, what's not?
It's I'm pretty amazed by the progress what we made in the last 10, 20 years because of Moore's law and cloud computing and the acceleration of GPUs. I find that AI is a particularly good subject for what I call data-defined products, because AI products are defined by the data sets. And from an architectural point of view, it is very good to separate the definition of the problem from the actual implementation of the problem, which is the model itself. So I'm thinking about AI as these two things together, and this is why I'm hopeful about the future, because this is a suitable property, and this is going to allow companies to engage with machine learning in the future and solve future problems that cannot be solved with imperative programming techniques.
Interesting. So interesting. You split the space of AI into two buckets. One is the actual data-driven problem solving, so coming up with the model and the data set and the knowledge and know-how on how to solve a problem itself. And then the engineering challenge of actually taking that, putting things in production and generating value, right? So let me ask you the question. And we talked about how you mentioned GPT-3 and GPT, those kind of big transformer models and stuff. What I see, and I think it's very evident right now, that AI requires a lot of resources to be successful, and mostly not just the solving the problem, but the infrastructure needed to solve that problem, right? If you're doing large data sets, if you're doing models that require a lot of compute power, not everybody can afford that, right? So, and in one of your blogs, you wrote about you are not Google. So, and I think you were talking about the engineering problem and not just the modeling problem, right? So what are the challenges that you see in enterprises deploying AI at scale? There is some statistic that goes 84% of AI projects never make it to production or fail. So where is the problem? Is it the modeling side? Is it the engineering side? Is it a combination? Explain that to us.
I think still the biggest problem is in machine learning and productionization is there is not a standard workflow how to solve this. So creating solutions around that is not straightforward. And the recent trends in machine learning is to try to solve the components piecemeal-wise and then hook them up together into one solid workflow. I think that is a symptom of type of pathfinding, whether the community is trying to figure out how to do it properly. And I think Google's ML maturity model, which is typical to the "you are not Google" question. Are you supposed to think about yourself on this scale? Is also a sign of this pathfinding, where the largest organizations are struggling with this, and they're trying to find a good thing. This is going to be simplified in the future, and when the workflow is simplified, you can start looking for simpler models which are making sense. I think on the BERT model, so the transformer model side, you have Distilbert and smaller models which are performing the same way but much smaller than the larger brothers. I think it's a trend. When the workflow will be simpler, the companies or the practitioners can think about simplifying and using it cheaper. But I don't think it is just a money question, because I read somewhere that when big data moved from local or personal infrastructure to cloud infrastructure, the companies are actually started to spend more money on that because they understood that the workflow became simpler and the management became simpler, and they had a better way to assess value, and then they realized that actually this is a worthwhile activity to scale it up and use it somewhere else and spend more money on it effectively, because that's one of the biggest problem is, as you said, 84% of AI projects fail. Then you have a much difficult way to express a cost-benefit analysis, because if the benefit is real, you have an 84% that you are not going to get that. And I think that is one problem at the moment with productionized machine learning.
Interesting. You mentioned that, and and I'm going to dive a little deeper here, right? But first, before that, is machine learning operations, the ML ops space. Is that going to solve this problem? And what's going on with ML ops today?
ML ops will eventually solve the problems of the technical aspects and the workflow, the operations parts of machine learning, where practitioners, machine learning engineers, data scientists can start thinking about business problems, because currently most of their efforts are spent struggling with actual solvable engineering problems. And that's one of the problems what I see in MLOps at the moment. And these problems need to be solved, whether it's the current vendors or future non-existent vendors or one of the cloud providers. There's products like Vertex or SageMaker. I don't know, but there is going to be a convergence.
Interesting. So let's dive into the solving the workflow or the ML at scale problem, right? And you what are the building blocks? If I'm an organization looking to solve my problem of going from doing a bunch of models with the data scientists and experimenting with it to really want to productionize it, go into production, give me a step-by-step approach. How do I go about it?
I know that usually this is described as a 4-step process, but I like to think in terms of an agile process of how do you maintain productionized systems. And if you think about it as an agile process, you can, exploit understanding of agile software engineering or engineering principles from software engineering, and actually bootstrap yourself into a much better position than, repeating the academic 4-step waterfall process. This immediately puts you into a position where you're not thinking about starting an ML product. You are maintaining an ML product, and your goal in scaling is to shorten the period between an idea and being operational. Once you are in operational, there is only 2 steps what you are doing. One, maintaining the data set, which is model monitoring, labeling, customer feedback, synthetic data, computational labeling, and all of these aspects are essentially the same thing. And even model evaluation, offline evaluation is the same thing. So that's one step. That's one major step. These are almost fused into one workflow. And the other is the actual training the model, the technical aspects of marshalling the computing power, and actually writing the model structure. In case of deep learning models, this is more convoluted, but I would put feature engineering here, any kind of productionized code reviews, testing the imperative parts, and deploying it into production. So you only have these 2. And essentially you are switching between these 2 steps all the time. Maybe it's not even the same team with different skill sets. Domain experts and data analysts can work on the data sets. You don't need a machine learning engineer to label data. And these kind of parallelizations can be exploited in scale. And if you have this workflow solved and implemented, you can start producing these workflows at scale.
So what about so you have the first part is the 2 parts you said is one is the ML side of things, collecting the data, making sure you're preparing it, and even building the model and so forth. And the second thing is the training, which is like you curate the data set, do the feature engineering, look at the infrastructure, make sure you're building the right outcome, right? So you get your model, it's in the right infrastructure, you've trained it with a set of data and stuff. What about what happens after? So deployment, production, monitoring, and things like that. Or are you saying these 2 processes will actually cover a lot of that stuff as well?
Yes. Monitoring is and I think this is a conceptual problem at the moment, that monitoring is seen as a afterthought or as a external activity to maintenance of a machine learning model. This is what I learned in finance, in quant trading, that you are never take your eyes off from a model. That is your responsibility. That while it is in production, it is working. It's the same as you evaluate an A/B test. Until the A/B test is evaluated, you are running these queries every day and looking that potentially external event are influencing it, and there is something unexpected. Monitoring is just continuation of evaluation of the data set and the problem and further defining it. So that's a crucial part, and this is why I fuse this data set maintenance into one aspect, because sometimes monitoring appears as a labeling task. Something unreasonable happened and you need to get the data out of the system and label it, and evaluating that is my assumptions about distributions or priors are still correct.
So how about training versus inferencing? So, for example, the environment required might be very different, right? Your data pipelines might have to be very differently orchestrated. How do you think about that in this two-step model, if you will? I want to come back to the notion of when you're building anything, you're building it for production from the get-go. There is no other way out, right? So I'll come back to that. But talk to me about the environments for deployment itself. So I believe deployment plays a huge role, right? Not just having the infrastructure ready, but you'll have to take care of different scenarios and deployment considerations when you want to run it in production. Security, lineages, and what libraries you use. There are so many different things than just the infrastructure footprint even. Talk to us a little bit, yeah.
That's a very good question, and touches upon a very important point, which is I also take from software engineering, which is called the hexagonal architecture, which essentially I think of models as business logic. And business logic in software engineering is not aware of its circumstances. So it needs to be detachable from the environment you are using it. And if you are using it in evaluation mode, where you probably have peak performances which are thousands of times more load happens on a model in inference time or evaluation time than in production, and then the same model need to perform in a secure environment, as you said, but it's not aware that it is in production, and that's what modularity creates, that you can treat models as business logic.
Interesting. And then on the other thing which you said, which is the notion that any data scientist building a model should always be aware that, yes, have to have the right infrastructure for them, but they have to be aware that this is going to be run in production, the quant mindset you mentioned. And that'll make sure that the loop of monitoring, tagging, whether things are working, whether you've identified the right features, all of that is now built in early in the life cycle than being an afterthought, right? But if you do that, what about, it's going to be a hard problem to solve, because what about separation of concerns, right? So there is the data scientist who's really good at one thing, and that's modeling and understanding the domain problem and solving it. The DevOps person might be the right person to understand CI/CD pipelines and how that actually works and how do I retrain and so forth, right? Explore that for me.
That's a good question, and I think you touched upon the right thing. What's probably a mindset problem in data science, that it is a research problem, and it's somehow modeling is somehow unique and it consumes all the energies of data scientists. And I don't think so. I think I wrote about this in my article of 3 roles in data science. A data scientist needs to be able to create the model that's going to eventually be in production, and maintain its own data. It doesn't need to maintain its own database. It doesn't need to maintain its own computing infrastructure, because that's first is data warehousing, the second is MLOps and DevOps. But they need to be able to prepare the data, write code at production level and write models at production level. There is no one to translate your models into some other language. Usually they say, okay, what happens if data scientists write code in Python and the production environment uses Go? Then the data scientists need to learn Go. It's not a magic language. If your data scientists work for this organization, you need to hire ones that will going to be able to learn Go and willing to do that work next to their own mathematical job as well.
So what you're really proposing is the definition of a data scientist today, role definitions even, honestly doesn't really comprehend all of that. I mean, there's a lot of wish lists from most organizations, but most data scientists I know are modelers. They don't necessarily understand software engineering as much as they should, as you're claiming they should, or they don't understand the infrastructure of how do you, what's the process orientation of putting things in production, doing it and stuff. What you're really proposing is redefine what a data scientist needs to be. Do you agree?
Yes, yes, I do. I do agree. And I think there are a couple of notions here. One thing, why don't we train data scientists in a different way? And one of the reasons for that is engineering is a very craft skill. It means that you need to do it on the job. And I think companies should spend more energy understanding that and saying that, okay, the academic training focuses on math and your modeling skills because they need to be focused and tested and validated through exams and stuff. But once you go into industry, you will going to get a rigorous training in software engineering on the job that you can practice. Our experience was that this is learnable on the job, and doing machine learning in a highly software engineer foundation is as good and as efficient as doing it in notebooks, and which created a very good workflow because software engineers spent 20 years or 30 years, the last 30 years on figuring this out. So why don't we just take the ideas, adopt it to ourselves, and make our life easier?
It's a fascinating idea, and I can attest to a few things there. Like, early in my career, I started, programming. You learn programming syntax in school probably, but you don't know how to solve the real world problems. I was writing, assembly and then C code and C++ code for firmware and drive caching and things like that, which you would never learn in college, but you learn it on the job, right? So when you're doing this, when you're solving these problems, and you're saying like in data science, you can learn the academic aspects of statistics, math, even write a little bit of how do you actually do how do you go about working with data and stuff. But when you're solving problems, having that knowledge or having the teachable skills that you can train data scientists on, and how do you think about writing software the right way? How do you think about, life cycle management of the piece of software that you write? And all of that aspects can be brought in. This is, very, very interesting, very unique because, there is, you can really attest to, there's almost everybody in the data science or like the associated space, whether it's companies or building new companies or existing companies, they all approach this problem and saying, how do I empower each of those different factions? How do I separate the concerns, not unify them, right? And then provide them each toolkits that they can abstract away from the other person. What you're saying is, as a data science, in the data science role, it's really critical. You have to start evolving a skill set that's beyond just traditional modeling data science, right? Well, fascinating. This is good. One quick question, and I'll go into some rapid fire questions after this, right? What do you think is the most critical piece of work that is happening in AI today?
It's interesting. From a theoretical point of view, I think the convergence of several major theories towards transformers and graph neural networks, and it seems to be that there is going to be a unified theory of AI in this area. And I think from a theoretical point of view, that's the most important one. From an engineering point of view, various workflows and workflow definitions and how businesses can define their business problems and business processes with AI and interacting with this. This is much less evolved, and I think Snorkel is probably one of the typical example of that. But I haven't seen anything else. Probably there is going to be emerging technologies here which are going to be challenged by the cloud providers.
Interesting. Can I double click a little bit on the unified theory of AI? Can you explore that a little bit for me?
I think since the Transformer paper, so I think that was probably about 4 or 5 years ago, I think there is a simplification of architectures towards a more mathematically describable technology rather than the sequence-based models before it through LSTM. And transformers are very plastic. And I think this allows a direct connection to graphs, which are a fundamental structure in mathematics. And I think these two things, when they're going to be meeting, there's going to be like some kind of unified theory that will going to allow scaling because of the simplicity of graphs and transformer models. And then we are going to be able to think of large-scale AI structures as some kind of computer layer, and we can define business problems on top of that.
That is fascinating. I can't, it is fascinating. I think there's a lot of opportunities there as you described. So here's some rapid fire questions for you. Okay, what's the most fun project that you worked on in AI?
That's a good question. Fun.
Or you can say working in AI is never fun, but I don't think that's the case.
No, that's definitely not true. I think we had one problem, which was a model that was detecting swear words, and after spending about half an hour on this, I decided that for Agile reasons, it is better if I personally do this as a founder of the company, and I'm not outsourcing it to any of my team members, because I don't want them to see swear words for several days in advance, because that's what you do. So you are detecting hidden terrible phrases in articles that are accidentally get into your news pipeline, which is supposed to be about finance and economics. But I can tell you there are some dodgy stuff there.
Interesting. Okay, next question. Give me an example of something that 10 years ago you thought was, impossible, or not even, it was like science fiction, and it's happening today, or it's very close to happening. Something that fascinates you.
AlphaGo is, I think that still counts as magic. It's an amazing technological achievement. I think they cut at least 10-15 years from the expected time that's going to be possible. And I am following what's going on with AlphaFold. I think that's going to be the next frontier. It's just a testament to DeepMind's capabilities. That's magic. What's commonplace now, I would say, is, and I'm still fascinated by automated image captioning. That is something which is so not intuitive, and I'm still fascinated that it's actually working. And if you look into under the hood of what's happening, you can understand it, but it's still surprising.
Awesome. Give me a story of how we will be interacting with AI in 100 years.
In 100 years. Maybe it's not even, we don't need to look for 100 years, but I think if you think at the moment, AI is usually used by a central place against you. I don't think against you, but you don't really have power over a recommender system or a news feed or any of these systems. And I think there's going to be more AI solutions which are an extension of you. And this extension will going to interact with another AI. And I think that we are going to see more of these where it acts as a second brain, or as an accelerator that makes you more efficient.
Everybody will have their own personal Jarvis to interact with all the different AIs, right? It's very true. I think there's a lot of interesting concepts there, even in the world of cryptography and zero trust and stuff too, wherein you can have these pseudonymity is another thing that is catching up, right? How do I have an online personality, a presence that is different from what I really am, and can I have one for my health? Can I have one personality for my social interactions? Can I have another personality for something else? I can see a role where there is an AI playing that role as an extension of you as an individual. Okay. AGI, artificial general intelligence. Do you believe in it? Do you think it's possible anytime in our lifetime? And what do you fear or worry about it?
I feel that at the moment, this is clearly a completely philosophical argument. So I don't think there is too much energy spent, both in terms of the major technological companies and the public, to understand of what's going to happen and what are the dangers. I think the recent dangers like biases or this fake news generation is more pressing problem. I can refer back to our conversation on the convergence of AI structures, transformer models, and graph structures that allow a scalability that anti-data centers are going to be one model. And I think that's probably going to be a path to something which is larger than what we understand now as a machine learning model.
Fascinating. If someone listening to this wants to get into AI today, where do you think they should start?
The internet, all the information is free. You can read everything. You can watch YouTube videos. It's actually amazing. At any scale, you find content for yourself, practically free, and you can advance at any time. And at certain level, you are capable of getting in touch with the people who are doing these, creating these products, and have a chat with them. It's a very close-knit community. There is not too many machine learning engineers. I see a statistic that there are 20 million software engineers in the world, and maybe only about 500,000 machine learning engineers, which I was surprised. I think that's an underestimation, but probably not by too much.
Yeah, no, and it also provides the opportunity to, like you said earlier, train these data scientists or machine learning engineers the right way. So when they become 20 million or 50 million for that matter, they have all the foundational thing too. So how can the viewers get in touch with you? Where can I find you on the internet?
LinkedIn is the easiest way. And I have my Substack newsletter, and where I write probably every other week.
Awesome. Laszlo, this has been a pleasure. Thank you so much for jumping on the show.
Thank you. Thank you for your time, and thank you for the opportunity.